Okay, I think we can start. So hi everybody. Today, last it was just actually practice, but it was first lesson. So for this reason, I did some introduction. But now it's actually our lecture. It will be 2 hours in total. So let's start. First, I will share my slides with you.
It's
okay,
clear.
in this case, let's start. So if you will have some questions, just switch on your microphone and ask. Okay, let's start lecture number 1. But before we start lecture, I want to make some announcement. So you know that in the Moodle, this course it's not yet was created. For this reason, I want you to notify that tomorrow will be labs works, and for the group IT23 and IT24, it will be at 8:30 a.m. at the room C2 240K. And for the other group, 21 and 22, it will be at 10:40 a.m. at the room C1 348K. Okay, so please do not miss labs, because it will be first labs and you need to be in the lab. So next, before we start, just homework. So please, on the weekends, read the chapter 1 of the course book Digital Electronics by Roger Toheim, pages 17 and 42. So at the end of the pages, you will see you will see some chapter review question you need to answer to this questions, because we will do, in the next week testing. If you will not read and if you will not answer, you could not, pass the test, because this test you will get some grades, and you need to prepare. So read carefully chapter 1 and answer to the questions. And also I uploaded to the chat review labs 1, so you need to review. So what we will do tomorrow on the lab. So just review, try to introduce yourself, but tomorrow I will explain in more detail. Okay. Lecture number 2, it is called Generating a Digital Signal and Multivibrator Circuits. But before I will start, I want to ask the questions. What difference between analog signal and digital signal? What difference?
Analog is smooth and digital only has 0 and 1.
Yes, right. So analog signal can have some intermediate values, but digital has only low or high value. So we can say 0 and 1. Nice. Okay, so today we'll study 3 types of multivibrators. So we will see what is in the next slides, and consider how they generate types of digital signals, analyze several multivibrator, and switch debouncing circuits. So also we'll analyze several logic level indicator circuits, but mostly we'll do it when we will read the chapter 1, because we don't have time to cover all the information that in the chapter 1. So understand some definitions, what is a high, low, and undefined when observing logic level in both TTL and small digital circuitry. So we will discuss about it in this lecture. And also I will introduce you with Multislim. It is a circuit simulation software that we will use in the labs. Okay, but before we start, we will work a lot with integrated circuits, because digital system, it's based on integrated circuits. So what is integrated circuits? So here you can see some circuit, and you can see this black box. It is actually integrated circuits, and so let's see some definitions. Integrated circuit, also called microelectronic circuit, microchip, or just chip. is an assembly of electronic components fabricated at a single unit. So integrated circuit actually consists of some active devices. Active, it is transistor and diodes, and some passive devices. It's capacitors and resistors. Okay, если in Russian transistor это транзистор, да, diodes это диод, capacitors это конденсатор, resistors это resistor. Okay, of course they're wired and built up and do some functions in the digital system. So mostly integrated circuit is based on silicon chip. Silicon, it is a кремний, да, in Russian. Okay, so actually we can divide integrated circuits in two types. TTL family, it stands for transistor logic, and SMOS family. So it's complementary metal oxide semiconductor. But do not worry, in this course you do not need to know exactly what inside of this integrated circuits, their operational principle, because this is a realm of electronics course. But here your task just able to utilize these circuits, because you will have some scheme, some circuit you need to just design, and you need to just learn how to use these devices to perform some tasks. That's it. Okay, actually here you can see some advantages, disadvantages, some definition of TTL and SMOS, but we will not go into detail. If we will have some time at the end of the lecture, we'll come back. But then you can at home just open the slides and read this information. Generating digital signal. So first in the labs, we will start by generating a digital signal. How can we do it? Simple. It's just we can do it manually by our hand. So here you can see some simple circuit. It consists of some switch. We call this SPDT switch. What does it mean? SPDT, it means actually it means single polar double throw switch. So you can see that it is connected to some battery, 5 volt. It is a ground, it's battery, and you can switch up or bottom. And if this switch is connected to high, we have here signal high. If it is connected to low, to the ground, we will have low signal. So just manually by hand you can create this kind of signal. It will be digital signal. So I think in the past it was used, just to transfer some information. Okay, but you need to know some terminology. So this process, when we switch this SPDT switch, this process is called toggle. Toggle means to switch over to opposite state. In Russian, toggle means переключать. So you should understand some terminology. To toggle, it means to switch in opposite state. But this kind of simple generating digital signal device, it has some problem. So this problem is called contact bounce. So actually when we switch, if you will see in more detail, if you will scale up, you can see here we have some bouncing, contact bouncing. So in Russian it will be дребезг. In Russian we'll call it дребезг, but in English it's contact bouncing. So first, when we switch up, when in the high position, you can see our voltage will increase at the point A, but due to some oscillation, some bouncing, you can see that the signal also oscillate. Then after some relaxation time, we will have stable high value. So this region is undefined region. So we have low region, we have high region, and we have at the beginning we have some undefined region. So it's bad. We need to eliminate this contact bouncing. So how can we do it? So there is a solution to eliminate contact bounce. So we need some actually circuits that can eliminate this one. So for example, we have this single pole double throw switch. that we use to generate a digital signal, and we connect and we send actually this signal to some debouncing, we call it latch, bouncing latch. It's some circuit that eliminates this contact bouncing. So after the signal will be debounced, it will have some nice square digital signal. Okay, but you should notice that after debouncing, actually our low position is not 0, and you can see that high position is not 5 volt. It's here it's a little bit bigger, it's a little bit less. So, but do not worry how this debouncing latch works. It's not a realm of our course, but we need to understand that if we have some contact bouncing, we can use some circuits, some debouncing latch that can eliminate this debouncing problems. So here you can see other simple circuit here with some push button. So my question, can we generate a digital signal by this push button? What do you think? Can we generate this kind of signal by this push button? It is my question for you. Guys? So actually when we press it, we will have high signal. For example, in this case it's 5 volts, but when it's open, it is not connected to the ground, it is not connected to the 0, and we have some undefined, and some undefined value. So this just push button we cannot use to generate digital signal, but we can use this push button, for example, to start some other circuit. For example, this will have some one-shot multivibrator that we will talk in next slides. So for example, you can start some one-shot multivibrator, and here you have some impulse. Okay. Next one. So actually we have in this course we will work with 3 types of multivibrator circuits. So first we call bistable multivibrator. So it's just this simple, this is DPD based one. So actually we connected this to the debouncing latch in order to eliminate contact debouncing. So actually by this bistable multivibrator, manually, by hand or just by some other signal, we can create this type of digital signal. Okay, next one we call one-shot multivibrator. So we can, in this case, it's just simple. You have some one-shot multivibrator, and you started by some push button. You just push button, and you will create a digital signal just as one impulse. We call this monostable multivibrator. So it is a bistable, it is a monostable multivibrator. Next one, it is a stable multivibrator, but also we call it free-running multivibrator. Why? Because in comparison with these 2 ones, you can see that it doesn't have any internal. We do not need to start it. If we will just power it, it will create digital signal itself, some series of digital signals. Here you can see. So in labs you need to assemble all of these 3 multivibrators. Okay, but today I will show how do it some of them. So actually in electronics we call this free-running multivibrator, we call this just clock, because it has some periodicity. Okay, how to wire a multivibrator? So actually we have 2 choices. We can assemble multivibrator by using resistors, capacitor, transistors, but it will be very hard, and it is not a realm of our course. So we will use second options. It is we just will use some ready integrated circuits. For example, here you can see some 555 timer integrated circuits. So of course we need to connect some capacitors, some resistors, but it's simpler, just using all of these active and passive devices. Okay, so first in the labs, your task will be to assemble, to design this a stable multivibrator. Also we call it, guys, can you hear me? Is it okay? See?
Yes.
Yes.
Okay.
Yes.
Okay, so the heart of this a stable multivibrator, it is 555 timer integrated circuit. So your goal, your task, you just need to able to utilize some integrated circuit to perform some functions that we will need in the digital systems. So do not worry, we will understand why we connected here 1 kilo ohm resistors. It is not the purpose of this course. The purpose of this course, just know some simple digital system, how to utilize them and try to assemble them, maybe in hardware version or by software simulation environment. Okay, so it is a heart of this multivibrator, a stable multivibrator. It is timer, this integrated circuit. So actually, to start it, we need to wire with some resistors, give power, and we will get this kind of signal. So now I will show you simulation. Can you see my simulation software?
Yes.
Okay. I need to open a stable. This one. It is okay. So actually, I wired this a stable multivibrator in the software that called Multislim. So actually, it will be on the computers when we will work at the lab. But also you can download from the internet this program in your own computers. So because it will be better if you will do also simulation at home. So let's start this program. So actually I start and let's check what kind of signal it give us. So actually we have signals from this output. Can you see this output? So I connected oscilloscope. Here you can see signal. Now what kind of signal now? High or low?
Hi.
Now high. So let's wait a little bit. Now what kind of signal?
Low.
Low. Okay, so actually we can change the frequency. For example, it is here connected to the light. When LED is light, what kind of signal? Now, what kind of signal now?
Low.
Low.
Yes, low, because this LED, it is a LED. It's not lightning. Now, it is
High.
High.
because it's lightning. Okay, let's change frequency. How can we do? Just adjust this capacitor. So capacitor, I said in Russian, it will be конденсатор. It has capacitance, емкость. So, for example, we will decrease. Previously it was 1 microfarad. Now I change it to 0.1 microfarad. So I will start again. So what happened? What do you think? What happened? Frequency is increased, right?
Yes.
So let's see here. Can you see here in the oscilloscope?
Yeah.
Okay, you will do all of this on the lab. So it's just some example of free running clocks. Okay, so let's come back to our lecture. Oh. If you will have here capacitor 1 microfarad, your frequency will be 1 to 2 hertz. But by decreasing this capacitor or by decreasing this value of resistor, you can change. If you will decrease, but you will test in the lab and we'll see its dynamic, what will be happen. Okay, next let's talk about the bouncing of switch. So before I already talked that we can create by this simple switch, we can create digital signal, but it has problem. So the problem is the bouncing. So in order to eliminate this debouncing, we need to first send the signal to the bounce latch or to some debounce circuit. So on the output, we'll get not this kind of signal, but we get a real digital signal without any this contact debouncing. So how can we do it? For this, we need to assemble the bouncing circuit. So also we will do tomorrow on the lab, assemble the bouncing circuit. So let's consider. Here you can see the same integrated circuit. To assemble this bouncing switch, you will use the same integrated circuit that's called timer 555. But of course, wiring will be different from the free running clocks, but we will use the same integrated circuit. So here you can see the scheme. How can we wire and assemble this switch debouncing circuit? But you need to pay attention to the signal. So when I push, when the switch is closed, what we'll have? We'll have high value. Yes, we have signal 5 volt, or can say just 1. But when I push again and when it is opened, it is this point F. You see that still we have some high value, and then after some delay time, it will be then we'll go to the low level. So we have some delay, but we can change this delay by adjusting maybe this this one. Yes, actually, maybe this. Let's check by adjusting capacitors. So I will show you simulation. I need to open. So actually it's the same circuit, but it was created on the multi-slim. So let's start it. So I'll start and I push the button. So please watch to the LED. So when I push, you can see I have here a signal. Okay, let's put here, do you have question?
No.
Okay, let's put here some digital probe indicate. So it will show us if 0, it means signal is low, is 1, its signal is high. Okay, so I will push. You can see 1, 0, 1, 0. So, but if I push and will stay, something wrong in the circuit. I need to check. But actually, this what was it switched the bouncing circuit. Okay, so let's see on the oscilloscope. Can you see signal? When I push, we have signal. but here we have some delay. So let me change this capacitor. So for example, it will be not 0.1, it will be just 0.1. And okay, I will open oscilloscope and let's. I need to start. I need to run, yes? So I think delay is increased. So let's change to bigger value, maybe 1 farad. Again, run. There is some dynamics, but it's not so profound. Okay, let's come back to 0.1. Let's try to change this one. Okay, push. Oh, here you can see, right? You have really delay. Can you see?
Yes.
So actually by adjusting this capacitor, we can really see this delay. Okay, so nice. So tomorrow on the lab you will try to assemble the circuit and simulate and try to change some values and see how the system will behave. Okay, let's continue by this one. We call it okay, we see it's next one-shot multivibrator. It is a one-shot multivibrator that give us just one shot, just one impulse. So you can see here we use other type of integrated circuit. This box, this ones, it is integrated circuit, but it is not this one. It is not previous one. Here we use timer 555, but here we'll use other integrated circuit. It's called 74121 integrated circuit. So we'll use other type. So you can wire actually how it works. When you push the switch, so at first you can see it is a ground. Here with our circuit is open. So actually on the input here we have what? We have 0. But when you push, you can see here is high value. We'll have some drop, but we will trigger this input by about 3 volts. So after you will trigger at the output, you will have actually two kinds of signals. From the output 6, you will have a normal output. It just will be one impulse, but also you have other output from the pin 1. It will be complementary output. It will be the same, but you can see it's in other direction. It is a positive, it is a negative. It's just, you know, they just opposite. So what else here? Okay, so let's see a simulation. I need to open. This one. Okay, let's no, not one. So let's put to this pin 5. Can you see pin 5B? It's our input actually. So I'll push. But it's not working, right? Okay, I will push. Yes, we have signal. One impulse. So please look carefully. Now I will push, but I will, you know, it is in the pushed position. You can see I don't have any signal. So actually, it doesn't matter how much, you know, I push and stay in this position, how much it is closed. It doesn't matter. You can just, you know, push quickly, or you can push, you know, in press. It doesn't matter. So how can we change the duration of the impulse? Also by changing capacitor. For example, let's try to change this capacitor. So how much it is? 0.1 microfarad. So let's do 1 microfarad. Okay. Can you see what has changed? Duration, right?
Duration is high. Yes.
No, the amplitude is the same. But yes, right, but duration is larger. Right. Okay, let's connect here. Let me remove the oscilloscope and I will connect LED, because when we connect LED, we can visually see what's going on. So I will push, but it's not work, right? Because I need to run. So I run. So I push and press. You can see it doesn't matter. So let me change the capacitor. Faster. Let's give 10 microfarad. So it's, you can see that LED lights longer, right? So actually tomorrow on the lab you will assemble this type of multivibrator, this switched bouncing circuit, and one-shot multivibrator. You will do all of this, you know, you will do yourself, and it will be some questions at the end of the lab's work I need to answer. Okay, but it's not difficult. So next, let's continue to our slides. Do you have questions for these 3 types of multivibrators? If not, then I will have question for you. So when the push button is released, open, the output is, what's the output? 1, 0, or undefined?
0.
0.
It will be 0 if it was connected to the ground, but it is not connected to the ground.
Undefined.
Undefined, right, undefined. Okay, next one, the bouncing latch is also called, how we call this? The bouncing latch is also called, this system is also called monostable, bistable, or astable. It's called bistable. Okay, next. The one-shot multivibrator used for generating the digital signal is also called, what's kind of? Mana. Yes, right. This free-running clock is also called a free-running multivibrator or mono, bi, or astable.
Astable.
Yes, astable. And the 555 timer integrated circuit is being used along with several discrete components. So we already talked about it, to debounce or to increase the voltage. For what reason we use this?
I think to debounce.
Debounce, because this switch have debouncing, and we connect this switch to this, we call this latch. We connect to this latch and it will debounce, but it has some delay. So how can we adjust this delay? How can we decrease this delay?
By regulating the capacitors.
What kind of, C1 or C2? We checked already.
C2.
C2. We tried C1, but it doesn't affect that, and it didn't affect. And now, and then we tried C2, and we see that it's actually affect the delay. Okay. The 74121 integrated circuit is being used as, this one is free running or one-shot multivibrator? One shot. So actually in the test, every week you will have this kind of questions, so it's not so difficult, but if you will read and be in the lesson, I think you can manage to answer all of these questions. Okay, so next one. So this integrated circuit has two outputs labeled Q and not Q. We call it not Q. Generating complementary or in-phase output pulses. How we call this? Complementary or in-phase? We call this complementary. It means opposite, not in phase. In phase when they're the same, but it's complementary, they're opposite. Okay. The time duration or pulse width of the output of the one-shot multivibrator is determined by the first option. Amount of time switch is closed to values of components C1 and R3. R3. So how can we change the duration of the impulse?
By the values of components C1 and R3.
Yes, C1, where is C1? This one, and capacitor R3, this one. Okay. So it will be the topic of the next. So how much time we have?
10 minutes.
10 minutes. Okay. Before we start, let me show you how actually we can create this S table. So I will create new blank So actually, it's intuitively, understandable. So it's not very difficult. You computer scientists, for you to use some software, it's not difficult. So I think you can, manage to utilize this program very easily. So first, we need to choose. Let me open this circuit. This one. So we need to assemble this circuit, okay? So for it, I need my sketch. Give me a few seconds. Okay, let's start. So first we need to find here. You click on the right button, and here you select a component. So here it has some database, but we need to use master database. So here it has some groups. Sometimes it's great to use this just search 555, and you can find timer. So actually we have this two type, rated and virtual. So I tried to use rated, but it's not work. So choose virtual. So I will choose, put it here. Okay. What next we need? What else we need?
Capacitors, resistors.
Capacitors.
Yes. How much capacitors?
2 capacitors.
I see one. Yes, and two resistors. Okay. So to find resistor, just just choose from the group. Choose basic. So basic virtual, not basic virtual. So here we don't have any resistors, so rated virtual. So here you can see resistor. So choose resistor rated. So we need second resistor. Then what else we need? Capacitor, you already mentioned. So let's find capacitor. So here we have two type, polarized and just capacitor. So actually it doesn't matter. If we will do real, assembly, it will matter. But here we do simulation, but you can choose polarized ones. And just here, choose polarized. So what else we need?
Battery.
Battery.
Like source of energy.
Let's find battery. So actually we find battery from the source. Here we have source, and you need to find DC. What does it mean, DC? Who knows?
Direct current.
Direct current, okay. So we need to DC power, this one. And also we need last one. What also we need? Ground, right? We need to here ground, here you can see ground. We need ground. So it is also on the source. Here just you need to type ground. So just choose simple ground. Okay. Actually we need so let's try to assemble, but here you see pins numbers, but here there is no pins number. So actually you can find in the internet, where is the pins number. So actually I already found and make some draw, and let's do it. So here you can see that one connected to the ground. Can you see here? So actually one, it is ground. So I connect, I wire. Pin once here, pin once, it is a ground. Okay. So next, we need to connect capacitor also to the ground. But first we need to rotate capacitor. Actually, you can connect here, or you can just, create other ground, it doesn't matter. So next, you can see 2 and 6. 2, it means trigger. This trigger. So actually, you can see that I need to connect 2 to the capacitor. It is a trigger, so I connect here. Okay, next, what I need to connect, I need to wire a resistor 470 kilo ohm to the pins 6, but pin 6 means threshold. So I will take some resistor, I need to rotate it. So I'll connect it here. Right? No, not here. So choose here. So to the 6 I said that it is threshold. So actually we'll connect it here. It's really interesting. Well, I need to remove this one. Then I will connect. Okay. Next one, let's check. We have here 7. 7, it is discharge. Discharge. So actually you can move. Discharge will be connected here. Okay. Next, we need 1 kilo ohms resistor. I will rotate it. Does it right?
It's already 1 kilo.
Yes. Next, we need to connect this terminal to the 4 and 8. So 4 it's actually reset and 4 it's VCC. Okay. Let's move it here. Here. The next, it is go to the reset. And also it goes to the it's actually strange why. Okay, let's check. Seems fine. So also we need ground. I just will copy and paste. And what we need to change value of capacitor, right? This one. How much it Okay, let's continue. I think time is over, so we'll continue in 20 minutes, right?
Yes.
Yes,
Okay.
yes.
Teacher, can you send it again?
What? Open the...
I mean labs, lecture 1, lecture.
But I already sent.
Because I can't see it.
Nobody can see?
Yes. I can
Okay,
see.
let me send again. It says that already uploaded, so maybe you need to check on the chat. Try to find, because it is already in this meeting. It should be.
No, we can't see it.
Okay, I will try now to fix it. So see you within the 20 minutes.